Hello and welcome. In this video, we're going to take a deep dive into the world of Git and GitHub. If you're a developer or just started writing code in any language, you want to pay close attention because it'll save you a lot of time and trouble down the track. If you never heard of Git, don't worry. We'll go over the basics step by step. And by the end of this video, you'll be working with Git like a pro. So sit back, relax, and let's get started. So what is Git? Git is a tool that helps us keep track of your code and make sure you never lose any of your work. And GitHub is like a virtual office where you can share your code with the world or collaborate with other developers. Let's say you're working on a new app and you have a team of developers working with you. You're all making changes to the code at the same time, and you want to keep track of who made what changes and when. That's where Git comes in. Git allows you to keep track of every single change made to the code, and it also makes it easy to revert back to an earlier version of the code if something goes wrong. And if you're working with a team, Git makes it possible for everyone to work on the same code without interfering with each other's changes. You may ask, how can Git help me for a personal project? Let's say you're working on developing a website. You've been making some changes to the code for a few days and you have a running version of the website. And then you decide to add a new feature. But what if the new feature doesn't work as expected and you need to go back to the previous version of your code? This is where Git can help you. With Git, you can easily switch back to an earlier version of your code without having to manually track every changes you made. You can also experiment with different approaches and easily switch back to previous versions if it doesn't work. Let's create a GitHub account for the first time. To do that, just head to github.com and press sign up. Here it will ask you to enter a username and email address. Just enter your email address first and press continue. You have to create a password for your account. Just bear in mind that the password has some criteria. For example, you need to have numbers and lower cases. So make sure you create a strong password and press continue. And just go ahead and create your username. So the username has to be available. So in my case, Dr. Tech Talk is available. So I can continue to the next step. It's asking me if I want to receive communications. I'm just going to say no. And here, I think it's just going to make sure that I'm not a robot. So it's asking me to complete these puzzles. Just go ahead and complete the steps. And finally, create account. So you need to enter the code that you received from GitHub in your email. Just go to your email and find the code and enter it here. And here, it's just going to ask you some questions, asking me about team members. I'm just going to say it's just me at this point. And asking us for features that we're interested. It doesn't really matter what you say, just let's select what you are interested now and press continue. Now I will select the free version of GitHub. You can select the paid version, but at this point I'm just going to continue for free. And now we created our GitHub account, and this is how our dashboards look like. I'm not going to go through all these tabs. I will get back to this if it's necessary, but just go ahead and browse through, just see what's around. Just check your profile, setting, and other parts. But what I will do now is I want to create my first project or my first repository. Just press create a repository here to create a new repository. Just name your repository whatever you want. I'm just going to say test one. So you can make this repository public or private. I'm just going to leave it as public. Public means that anyone can access the repository. So I don't want to make it private at this time. And then press create repository. Now this is how a repository looked like when you first created it. Now we have GitHub account. The best way to use GitHub is to set up Git on our local computer. Git is a open source or free version control system, and it's responsible for everything GitHub related. So now I'm going to show you how to set up Git on your local computer. If you feel lost, just follow along, and it will all make sense. Okay, let's set up Git on our local computer. To do that, just go to git.scm.com/downloads, and you can see the downloads for different operating systems. We are going to use download for Windows. Just click on download for Windows, and it will give you some download links for different versions. I'm just going to click here to download for latest 64-bit version Git. It will start the download process, but since I already have the downloaded file, I'm going to stop it. I'm just going to show you what it looks like. After your download is done, you will see something like this, which is an executable file. Just double click on that, and it will start the installation wizard. So it will pop up something like this. So you need to agree with the terms and conditions first, obviously. Just press next, set up directory, just keep it as default. Now here, I'm just gonna click on the desktop, add icon on the desktop, and click next, and keep Git as it is, click next. Here we can choose our editor. Since I'm using VS Code or Visual Studio Code, I'm just going to select Visual Studio Code, but you can select anything you want. You can select Notepad or anything you want. And after selecting this, to click Next. Now, I'm just going to leave this as default. We'll see what this means later. Just keep it as default. Click on Next. And again, I'm not going to touch this, just keep it as default. Press next, and we're using OpenSSH in our Windows as well. Just click next, next, and just leave this as it is. Just click next, and use the default terminal. That's fine. Just press next and next. Since we installing this for the first time, I'm just gonna leave everything as default, and you better do the same. Just keep everything as it is, and finally press install. So it will go ahead and install Git on our local computer for the first time. All right, now I'm just gonna launch Git bash. I don't want to see the release note, and finish. And it will provide you with a terminal like this. When you run git bash on your Windows machine, you will see something like this. All right, now I'm just going to show you how to install it on WSL or Visual Studio uh, Windows subsystem for Linux. So just open up your Windows terminal and your Ubuntu WSL. So I've got Ubuntu terminal running. You only need to type in sudo apt install git. So this will install Git on our WSL Ubuntu machine. And if you write Git version to make sure it's installed correctly, it will provide you the Git version. So this now is exactly the same as our Git bash here. This provides the same environment we can use in both. But I will be using Git in WSL from now on, but you can do exactly the same thing that I do on WSL on Git bash as well. Now that we have Git installed in our system, let me show you how it works. First, we start with a project directory. This can be any folder that you want to store your project or your codes in. Now, the first thing that we need to do is initialize Git inside this directory. And we do that by git init command. When you run git init for the first time inside the directory, it will create a .git folder inside the project directory. And within this .git folder, it will create all the files, configurations, and programs necessary for Git to track our code or our files and communicate with GitHub. So it will automatically put everything inside this .git. So now let's start with making some changes, adding new files to our project directory. Let's say we create a new file, we call it file1, and we put in some code inside file1. So we write some code in any language inside the file1. It can be text file or whatever. Now, there are two steps to track all the changes that we made inside the project directory. The first step is called staging. And it means that we're telling Git that we want to track whatever we did inside this file. So we have to tell Git that track this file for us. And we do that by git add and the name of the file, in our case file1. And when you run git add file1, it stages this file, meaning that it knows that it has to track this file now. But nothing's done yet. The tracking is not complete until we commit our changes. So we run a command git commit to commit all the changes that we made to file1. When we run this command, now Git creates a snapshot of the project. It's like a backup. So it stores all the changes that we made and creates a snapshot or a dot in a timeline, if you like. Now, every change that you make during this project will be stored in a timeline we call branch. So when you first initialize Git, it will automatically create a master or main branch for your project, and it will track every single changes on this branch. Now let's say we want to try a new thing. For example, we want to add another file and we want to try a new piece of code and we want to see if it works. And we don't want it to interfere with our main project or main branch. What we can do is create another branch from a specific point in the timeline that we have using git checkout-b and the name of the new branch command. So when you run this command, it will create a copy of the code or a copy of that point in the timeline, and every change that you make after that point will be stored in a new branch called dev, for example. And all these changes will not interfere with the main branch. In any time, you can go back to the main branch. If dev doesn't work, you can delete the branch and everything will be the same as that point in the timeline or that snapshot of the project. So now that we have a basic understanding of how Git works, let's go ahead and play with this a bit. All right, now let's see what we've learned in action. For this exercise, I'm using VS Code, which is running on Windows subsystem for Linux. I have a separate video on how to install and set up WSL and Visual Studio Code, which you can go ahead and check. But if not, you can use only the Git bash that we installed on our Windows system. But for the rest of this video, I'll be using Visual Studio Code and the WSL terminal within Visual Studio Code. All right, let's get into this. I am inside a project directory. I've created a new folder or directory and I called it project. You can call it anything you want. So the first thing that we need to do is initialize Git, as we've learned. So the command for that was git init, and it says initialized empty Git repository in this directory. So this means that a .git should be created inside this directory. So if I say list all of the things here, it shows .git. You can see here, this is a directory that is created by this git init command. As I said, all the config files, other programs and files required for the Git version control and also GitHub will be inside this .git directory. This shows that we initialized Git in this directory. Okay, so when I ran git init in my terminal, now it's showing git master. So it may not show this in your terminal depending on your configurations. But if it's not showing, you can easily check if Git initialized or not, or on which branch are you. You can easily check that using git status. So if you press enter, if you enter this git status and enter, it will show that you are on master branch and there's nothing to commit yet or nothing to do yet, because there we haven't done anything to this directory. Okay, now I want to create a new file here. I want to say file1, and I want to create a Python file. Let's say Python file1.py. Okay, now I have a Python file created here, and I want to run, say this is my first line, and I want to say print my first line of code, and I want to save this. So I've created a new file and I added some stuff into the new file. I actually can run this file now using Python, and if I run it, it's going to print my first line of code. Okay, now as we just learned, we need to stage this file, which means that we need to tell Git to start tracking this file. If I say git status again, you see it's showing untracked files and the file 1 here. It means that Git understands and knows that there's a new file and there's a new change. But you should remember that Git does not automatically record every change you make. You have to specify what file or which file and when to record the changes. So therefore, we need to stage this file, and the command for that was git add and the name of the file. So when we do this and check the status again, it says that now it's green, changes to be committed, means that it's staged. Now the changes inside this file will be tracked by Git, but nothing's committed yet. We're just saying that, okay, now this is the new file and we want to track this, but we will tell you when to record the changes permanently. And to record the changes permanently, we just learned that the command is git commit, meaning that I'm committing the changes, and with -m command, which you can enter your commit message. For example, I'm going to say my first commit and enter. And if I run git status again, it says nothing to commit, working tree clean, meaning that we created that first dot point on our timeline. We tracked this change on this file now. And we can always check the history using git log, and it shows that this is my username, this is my email, the person who made this commit, and this is the commit ID or hash key, they say. And the commit is done on the master branch, and the date and everything. So let's say we add another line to this code and say print my second line. And this time I'm intentionally introducing some errors. So I know that this code's not going to run, but this is just intentional, right? So let's say I made another change to this file and there's an error. And when I try to run it using Python file1 again, it's going to throw an error, obviously. And let's say you don't know where error happened. You wrote 100 lines of code and you can't debug it and you don't know where is it. And you accidentally committed this new error to your code. So let's say we add it again, git add dot. So this dot here, it means that add everything that is changed. So that dot means everything. So you don't have to specifically mention the file names separately. If you just say git add dot, it will stage everything that is unstaged. And if you check the status, means that it's staged everything. And now we can commit this new change, my code with error. This is our message, our commit message. All right, so we created a new dot point or new snapshot of the code on this master branch or this master timeline. And now we realized someone else mentioned that, hey, I tried to run this, but there's an error. So, and you don't know where the error is. Now we want to go back. So this is where you can revert back to the previous running code, right? I'm just going to show you how to do that. If we check the git log, it will show us 2 commits because we have done 2 commits. And these commits, as I said, are the snapshots of the code on this timeline. We can go back to any of them whenever we want. And each commit has a hash key or an ID associated to it. So we need this ID to go back in time to that snapshot. So in our case, we want to go back to my first commit, and we don't want this code with error, which we accidentally committed to the GitHub, to our Git version control. So what we do, we can just copy this key, Control C, and we can easily say git checkout and paste that key here. So we want to check out to this point in time. And if I press enter, and you see the file changed actually. So that second line that we added, now it's not here. So we went back in time, and we now running the first commit, running that snapshot of the code. Now what we can do, it actually tells you what you can do now here after running that command. It actually says that you are in detached head state. You can look around, make experimental changes, commit them. You can create a new branch and create, you may do so now or later by using C, blah, 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 and all the things that you can do, it will tell you here. Now, let's say, okay, I reverted back my code. Now, I want to create a new branch and then take it from there. So, as we've just learned, to create a new branch, we say git checkout-b, and the name of the branch, I want to call it dev. Okay. So you see how the name of the branch changed here? It says switch to new branch dev. Now we are inside a new branch. Now let's add another line of code here. Let's say I want to print my second line, and I want to save, I want to save this, and I want to add or stage this and commit this added second line and enter. So now we're working on dev branch, right? So whatever we do here will not affect the main branch that we had. And let's say we now have a working version of the code. We can test this Python file 1. We see that it's working, everything is good. So if you want to make sure that this second line that we added did not interfere with our main branch that we had, we can always go to the main branch using the checkout. Again, we can say git checkout, git checkout, it was the master, the name of the main branch. So depending on your configuration, the default branch is either called master or main branch. So in my case here, it's called master branch. So if I say git checkout master, you see the code with error still here. And we cannot run this code actually, Python file 1, and it will throw an error. So this was the code with error master. But we created a new branch dev, which we can go back to using again git checkout dev, the name of the branch, and we're inside the dev, inside the running version of the code. Now, if you're using VS Code like me, there is a really interesting extension in VS Code that you can install. It's called Git Graph. So just go to the Extensions tab and search for Git Graph. So Git Graph this one, and you can install this on VS Code. So this Git Graph, it shows us exactly what's happening on this Git timeline. So if you go to the source control or Git extension here on VS Code, the Git graph is showing up there at the top. So if you click on this, it will exactly show what's happening in our Git directory or in this Git timeline. For example, it's showing that, okay, this is the master. So as you can see, this was the first command when we initialized Git. This is our head. And then we created two branches. One is master branch, another one is dev branch. So it's really interesting. It's showing exactly what we've done, all the branches with different colors and stuff. So if you want to see really what happened or who did what inside the your project directory, it's really a really interesting visualized way of representing what happened. So I highly recommend you install the Git and Git Graph extensions in VS Code. All right, we will get back to this a bit later, but for now, you may ask, so what happened with the GitHub? All right, so far what we've done, it's all stored in our local computer. We haven't published it to GitHub yet. We have created a GitHub repository, in our case test1 we called it, but whatever we've done so far, it's stored on our local computer. What I forgot to mention earlier is we need to set up our Git configurations for communicating with GitHub. We need to set up our username and email specifically. And to do that, just go to your terminal and type in git config -- global, and username should be your username that you created in GitHub. So just type in your username and it will configure Git with your username. It won't ask your username anymore. And same with the email. So just type in git config -- global and user.email and your user email. This is the same username and email you signed up to GitHub with. Okay, and press enter to check if you have the right configurations. Just type in git config and user.name, and it will show you the configuration for the username, in my case Dr. Tech Talk. The same goes with the user email. You can check what user email you've set up with git config user.email. Now, how can we publish all these changes that we made, all these branches and all the changes that we committed to GitHub? So to do that, we can go back to our empty GitHub repository, and it actually shows us what to do. So the first bit, we already did that. We initialized, we added some files, and we committed some changes, and we have some branches, yes. But to communicate with GitHub, we need to add a remote origin. And it's showing us how to do that. It says you need to say git remote add origin. And this URL that you see here, it's the URL for this specific repository that we created. So you can either use SSH or you can use HTTPS, doesn't matter, whichever you choose. You can copy this line and go back to your terminal and add that origin. And now we can check this by git remote -v, and it's showing here that it in fact added this URL to our remote repositories. After we've done that, to publish whatever we've done on our local computer into GitHub repository, we have to say git push origin. So the name of this, we call it origin, the name of this repository. So we have to specify the name origin, git push origin. And so now if we only say git push origin, enter. So it says to push the current branch and set the remote at upstream, use set upstream. Okay, because we have two branches in our project, the Git doesn't know which branch goes where in our GitHub repository. So we can either specify that using set upstream, or we can say git push origin and say that we want to push dev branch on our local computer to dev branch on GitHub. You can specify the name of the branch that you want to push to. So if I say that, it will go ahead and ask me to continue connecting. I say yes. And it says permission denied, public key. Okay. Since this is the first time that we're communicating with GitHub, we need to authenticate our user, or we need to somehow tell GitHub that this GitHub belongs to us. So the user needs to be authenticated. So I want to go back to my WSL terminal, and this is the same thing that we have here. This terminal is the same thing, right? So just to show you better, I'm just gonna make it a bit larger. So again, let's say if we say git push origin dev, so it's gonna throw a error for us. So I will show you later how we can add our public key, how we can add SSH key to our local computer to be able to communicate to GitHub. But for now, what I'm going to do, I'm going to add the HTTPS link instead of SSH. So I'm just going to copy this line. Instead of SSH, I'm going to copy HTTPS line and run this git remote add origin HTTPS. Okay, it's not going to accept this. We need to add remote update URL was the command, I believe. Update URL, no, set URL. Okay, git remote set URL origin. I'm resetting the URL for origin for the HTTPS instead of SSH. Now if I say git push origin dev, it's gonna ask for username and password for us here. So just go ahead and type in your username and password for the GitHub repository. And this is not gonna accept it. So this is because GitHub changed how it authenticates user. To solve this issue, so if you just go and say git push origin dev and you put on your username and password and it will throw up this error, don't worry, it's not because you put your username and password wrong, it's because another thing that you need to do to authenticate yourself. So this method of authentication depreciated in GitHub, a recent version of GitHub. So you need to copy and run this line of code if you're using WSL on Windows system. If you are using Git Bash, I don't think that you need to run this because it's already set up. But if you're using WSL and you see this error, just run this command, git config. I'll put this command on video description. You can just copy and paste it. And this command will only work if you installed Git using default parameters. Same as what we did when we installed Git. So we didn't touch anything. We left all the parameters the same. So if you installed the same way as I did, you can go ahead and run this command and it will set up the credential helper for Git. So after running this command, if I say git push origin dev, what it does, it's now getting to Git credentials and it will pop up this window. Now Git knows how to handle the authentication. So it asking us to sign in to the GitHub. So I'm just gonna sign in using my browser. You can just go ahead and click this and it will ask me to, I can just go and open this here and it will ask me to authenticate. So authorize the Git credential manager and enter your password and confirm. Authentication succeeded. Now we will have, all right, now that authentication is succeeded, we successfully pushed all the changes to the origin or the GitHub repository that we created. So if I check my GitHub repository now, and if I refresh this page, now you'll see that the file one is here now. And all the commits and everything that we've done, it's all here in the GitHub repository that we created. Now this project directory is now linked to this GitHub repository. And you saw how we publish our changes to GitHub repository using git push. Now let's say someone else made some changes and pushed to this repository. Let's say you gave access to another developer to this repository and they made some changes, they added some files and pushed this repository. To simulate that, I'm just going to add a file here I'm just gonna say this is another file with the developer, and as you can see, you can add files or commit new changes from GitHub repository itself as well. So I added a README file. It's a new file that I added on inside the GitHub repository. So as you can see, the new file is not showing in our local system or local directory. So what we can do to sync up these two is to run git pull command. But it's gonna say that set tracking information and do this set upstream. Okay, so first let's just set the upstream to origin dev, meaning that I want to link or sync the dev branch in our local system to the dev branch in origin or the GitHub repo. So now it says branch dev set up to track remote branch dev from origin. Now if I say git pull, it will update the local directory with the README file that I just created. This is another file. Now it's all synced up. Same file here, the same file that we have in our GitHub repository.